Good morning, everyone. It is my favorite day of the week, Hackster Café. Today's guest is Carl Bugeja. And welcome, Carl. How's it going?
Hi, Alex. Thank you for having me.
Oh, my pleasure completely. So you may know Carl's work as someone who's working on lots of PCB-based, flex PCB-based motors and LED displays and things like that. Carl, could you tell us a bit more about what exactly you build?
So the projects I build usually consist from a PCB. It can be FR4 or flexible, and I usually try to combine PCBs with magnets. The whole concept is for actuators. I make a voice coil actuator, which is coreless. So a coil printed from a PCB track that can attract or repel magnets, or even get attracted or repelled by magnets.
And what all does that enable? You can make motors and speakers with that? What are you doing with it?
So I have done both. I have done motor speakers. I have done some linear actuators. I have done also robots. So from building, for example, a PCB motor, I try to use that motor and combine it into a robot. So a PCB robot.
That's so cool. What does your PCB robot do?
So far, I have created multiple PCB robots. I have created my recent one is a robot with two wheels that uses a three-phase PCB motor. So basically, by driving the two motors, it can run. It's still a prototype, and obviously the results are still. But I'm also working on version 2, which should be more robust. I've also done a flexible PCB frog, um, which the concept is like it's a double decker PCB. It has
Is that
four
this
coils.
one?
Yeah, it's that one. So it has four coils underneath and four magnets on top where the electronics sits.
So this is like an electromagnetic system where are you just powering and depowering the coils underneath and then the attraction
Yeah,
of all the magnets?
basically that's what I'm doing there. I'm applying a square wave, and I'm on that video I tested multiple frequencies and stuff like that.
That's so cool. I love watching this thing go. Oh, that's great. Tell us about tell us about where did it go? This. What's happening here?
Okay, so that's basically a video I made a few months ago, where I was testing some stuff related to PCB heaters, and one thing that I noticed was that for flexible PCBs, when you apply an over voltage, they literally start puffing up and then catch on fire. And I also observed it with that sample, which has an FR4 substrate. It basically has the material inside it is rated for around 120 degrees Celsius. So
Wow.
that's why it's basically that the temperature it exceeded, I think, 400 degrees. So
So anything over 120 degrees Celsius and the FR4 that the PCB is made of just literally catches on fire.
not I don't think it's 120, but
Oh,
it's
wow.
for at an excessive temperature like that.
It certainly looks excessive. And you just did this for fun to sort of test the materials
Yeah.
out. Cool. What led you down this road? I've been following you for a few years, and you've been doing this for, definitely at least like 3 or 4 years. How long have you been up to this, and how did you get
I think
started?
something like that's around 4 years. So I started making things before starting my YouTube channel and posting stuff online. But basically, I graduated in electrical engineering in 2016. And right after that, I obviously wanted to keep experimenting with robots and stuff like that in my free time. So basically, somewhere between, I started a YouTube channel, and it sort of took off, and I kept making projects and posting them on social media on Hackster.io on
Yeah.
YouTube, and most of them are open source. So I mean, people who are interested in them can also make them. Maybe get some hands-on experience on this new technology.
Yeah. So show us or tell us a little bit about this wheeled robot that you mentioned earlier and is one of your most recent YouTube videos.
So that will draw what first. So that prototype motor that I'm showing there, it's the second PCB motor I made, but it was I made it 3 years ago. So I never actually used the PCB motor for
Huh.
something useful.
It was just an experiment at that time.
Exactly. At the time, I wanted to make a PCB drone, but from the results I got so far, it
Mm.
was the thrust to weight ratio. It's not there yet. So
Ah.
um, then I had this idea to make a PCB wheeled robot. So basically, you have the PCB that acts as the stator, a bearing, a shaft, and then you have the rotor, which interestingly enough, the rotor can also be made as the wheel itself. Since I'm customizing it, I mean, I don't have to make a rotor and then attach the shaft to the wheel. I can just make the rotor the wheel itself. So that's an extra advantage of making a DIY motor.
Right. It's because the motor is the wheel, so you don't have to have a
Exactly.
separate. That's so cool. I also love how you put your little diagram as part of the. Oh, this is so cool! As part of the silk screen on the robot. I could just watch this forever. And people do. You've got over 103,000 subscribers.
Yeah, I'm very grateful for that.
That's so cool. I see you got your YouTube silver thingy up here.
Yeah, I received
And you
it.
got married. Congratulations.
Thank you very much.
What an exciting life. What else are you
Yeah.
excited about right now? Or do you have anything anything else big that's on the horizon for you?
So I currently took a little break since I got married, but now I got back into making, and I have a couple of new projects lined up, which I'm very excited to share. Um, and I'm also want to experiment with new things once I finish these projects.
We have a question about PCB heater V2.
Okay.
I'm sure you probably, as you just said, you don't necessarily have a timeline for that right now, but tell us about the PCB heater project.
So I already made version one. So version one, I wasn't very happy with the final results because basically there were some things that I got wrong, and also I made the entire PCB entirely out of an aluminium, um,
Ah,
which for those for anyone who ever used aluminum PCBs, they are quite tricky to solder and debug. So it was not that good of an idea to make
mm.
the controller, the first version, out of aluminum PCBs. But eventually, I still got it to work, which is what you're showing right there. I had to cut off some extra tracks to get the resistance right. But now,
Mm.
obviously, I'm thrilled to start working on version 2, which I'm planning to divide into multiple videos. This idea actually started from another thing which I'm also going to dive into,
Ooh.
which is self-reflowing PCB. So
Whoa, what?
yeah, this project actually I had this idea to make to have a 4-layer PCB and embed one layer. It would have a a track that acts as a heater to reflow the PCB. So that's where the idea started.
That's incredible.
But from an engineering perspective, I thought like that's a cool idea, but I need to start from something from that. I mean, that looks like step 4. I need to start from step 1. So this is what I'm showing here is my first attempt in doing that. So the idea was to first try and create a heat bed or a hot plate.
I love this idea of the self-reflowing PCB. So you'd have a track in the middle of it that would heat up to reflow the top where the components would sit, or the bottom. That seems like it would solve a lot of problems for people with being able to heat the
Yeah.
less sensitive parts of the PCB more, and like keep less heat away from sensitive parts like the chip and stuff.
Yeah, that's I think one of the challenges for makers and engineers as well is soldering. So starting to learn how to solder. So I
Mhm.
think that idea would sort of remove one extra step from the process, which I think would be very cool. So that's a whole project that I am currently thinking about and also working. So the heat bed that someone um, asked about, that is the version 2 hot plate that I'm working on. The design is almost finished. I'm just waiting for the PCB manufacturer to confirm the files.
Cool. Who do you use to manufacture your PCBs?
So I manufacture. They are actually one of my channel sponsors. It's PCBWay.
Uh-huh. And you said that you would be doing something different because you didn't like how it came out with the aluminum being used as the substrate for the entire board. So what would you do next time?
So next time, the part where I'm calling the hot plate is going to be made from aluminum PCB, um, and the controller part I'm going to make to have it manufactured um, as an FR4 material, which would be rated up to 170 degrees Celsius, the FR4 substrate.
Hmm, so cool. We've got this PCB speaker of yours up here, which you mentioned earlier. Can you tell us a bit about this? Like, how did it work? What was it a good experiment? Well, I guess it's always a successful experiment, whether the thing works or not. But what did you learn from this, and how did it work out for you?
I learned a lot from this project, and since I think this is also 3 years old or 2 years old, but this um, after I graduated in engineering, a lot of things I design is digital. So I for this project I had to go back to my old roots and sort of design an amplifier for it,
Hmm.
and it was really interesting. I wish I could dive a little bit deeper and maybe design a version 2, but I mean, the, these projects sort of take a lot of time to make, so then you have to prioritize between projects.
Yeah. When you're doing this, do you usually make, so it looks like the coil here is the actuator, and then you have the magnet attached to the diaphragm, in this case a plastic cup. It's interesting because that's kind of backwards from how usually a
Yeah, yeah. So I tested both scenarios.
mhm.
One with the magnet connected to the cup that acts like a diaphragm,
Uh-huh.
and then you have the coil fixed. And then I also tested having the magnet fixed and have the flexible PCB act as the membrane.
Hmm. Which one of those worked better?
I think the cup worked better because it produced louder sounds since it was moving more air,
Hmm.
and the flexible coil had a smaller area, so it doesn't I mean it's not going to generate the peak audio that a cup would.
That makes sense. So, this is one that I haven't seen before. I must have
Okay.
missed it on your page or whatever, but tell me about it. It's you've got a spiral cut out of the PCB here.
Yeah,
And
last Christmas I wanted to make something interesting. So
oh,
that combined. So I had this simple idea of making a flexible Christmas tree that sort of unfolds. Um, and I also combined that with testing transparent PCBs. So that material you're seeing there is translucent.
right. It doesn't even have much of that yellow tint that you often
Yeah.
get. Ha! Super
But
cool.
the disadvantage of that material is that it's rated for lower temperature. So I forgot what's the exact temperature it's rated at, but I if I remember correctly, cannot exceed 160 degrees Celsius, something like that.
And you said that's an advantage?
Disadvantage.
Oh, disadvantage.
So when soldering, for example, when I tried
Yeah.
soldering it with a normal solder, and it sort of started burning up.
Oh
Uh,
no.
so I had to use a low temperature solder paste for it.
Hmm. I want to bring us back to this PCB two-wheeled robot because I didn't show everyone the part where it actually rolls around. So let's take a look at that, and maybe you can tell us a bit about the microcontrollers that you use in here
Okay.
because yeah.
So for I Okay, so for the microcontrollers, I usually try to stick. I know that I would love to have time to experiment with different microcontrollers, but usually that's given the time frame of these projects, I don't usually have time to explore a lot of that. So I usually like to stick with the same microcontroller families that I'm familiar with, and um, I mean, IDs that I'm familiar with, so that even the time I take to develop the code would be more efficient.
Right.
Uh, so I usually like to use pick microcontrollers, and for the Bluetooth, that robot you shown has a Bluetooth module on it. Um, for Bluetooth, I like to use SciBLE module that
Mm.
is from Cypress Semiconductors. The reason why I use that module is because it has a 10 millimeter by 10 millimeter package.
Oh,
Um,
that's nice and small.
yeah, and there's not a lot of Bluetooth modules that are that size. Um, I think there are only two others that are smaller or equal to that size, and it also has the list of certifications. So if someday for example, would for example sell the one of the robots I make, I could easily sell it with the certifications that it
Mm.
has. So that's I think a small trick that not everyone follows. Given that, I mean, if you're not selling something, it should be okay. But when selling stuff, you need to make sure that it has the correct. It's go
The you have the certification sort of built in so that you
exactly,
don't have to
exactly.
worry about it. Yeah.
Exactly, because to make to certify something, it would be costly. I
How
mean,
does how does are you actually selling products right now?
so currently I'm only selling an actuator,
Mm.
which I call Flexor.
Mm.
Um, there were a lot of positive feedback on that product, and I'm also currently thinking about selling a driver soon. And if the results of the PCB heater go well, I'm also interested in selling some more PCBs related to that project.
Mm. let's talk about this Flexar project that you have, this actuator here. It's also the base of your Flex LED display project,
Yeah.
right?
So basically, the that that PCB has a coil in it, which is the coil I usually use um, for all my flexible projects. One interesting thing that some people sort of ask me, why don't you sell, for example, the flexible LED display? Or with Flexar, I sort of had the idea to first start selling the actuator and see how that goes, and see, because I mean, when you decide to start selling stuff,
Mm-hmm.
um, you, along the way there will be some issues that you will not foresee, obviously. For example, for Flexar, one of the issues I found was the resistance tolerance. So for example, one coil is 20 ohms, another one would be 18 coils, 18 ohms
Oh
for from a
no.
different batch. So that's sort of a positive thing I got from selling this actuator. So learning from what happens when you must produce coils of this type.
Yeah, so they're not, I guess the PCB houses weren't necessarily used to producing things to such a tight tolerance.
Exactly. So, other alternatives of that would be, for example, to produce to have resistor trimming, for example,
Mm.
which would be a very interesting thing to have for these type of projects. Um,
Did you come across that even when you were using the same house for multiple batches, like between the batches, even though it's the same producer?
yeah.
Ah, wow.
So that's an interesting problem.
Yeah.
I dove a little deep into this problem in one of my videos. So I
Mm.
went to my local university and also examined some quiz under their X-ray inspection machine,
Huh.
um, which I managed to find out some variance in the track width of the coil. So it's quite interesting when you start examining the small little details of these types of projects.
You have so many amazing videos on this YouTube channel. I was curious about uh the one that you just mentioned where you would be going to try and figure out how to fix the variable resistance on the coils problem. But there's just so much. I'm getting distracted, like just trying to like uh oh, there's way too much to explore here. It's incredible. So everyone, of course, you can find the links to this in the description below. And if you're having as much problems as I am in terms of like just getting distracted by all the shiny things, that's where you go. After the interview, check it out. um, Tell us a bit more about monetization, because you do release a lot of stuff open source. You've got these things on Hackster. People can go find your projects there. Uh, do you run into any challenges with the interaction between open source and monetization, or is it pretty easy to balance? Or does it feed it? Is it an advantage to be open source?
So my before I started my YouTube channel, I didn't used to publish my project as open source, but after doing it, I mean, I'm quite um, in favor of doing your project open source. Obviously, not everybody agrees, but in my experience, I mean, if you, for example, it can also, for example, there's the risk in someone copying you, obviously,
Hmm.
or someone starts selling a copy of your PCB somewhere abroad or something like that. But there's the advantage that you can start building your own community. So if,
Hmm.
for example, I had some cases where somebody like literally started messaging because he saw an advert of a similar PCB or someone doing similar stuff, and it's quite. I mean, the community will acknowledge that you are the creator of that thing, and
Hmm.
it's also quite a positive, like you're sort of helping others to create similar
Yeah.
stuff that you like. So there's that positive vibe there as well.
Yeah, there's speaking of which, there's so much positive comments coming in about like everyone who loves your work, loves the things that you share. People are very excited to see you on Cafe finally. Ah, absolutely same here. As I said, I've been following you
Thank
for
you.
years, and it's just so exciting. I was recently enthralled by this Flex LED project of yours, which again is sort of an update on the Flexar project. You can see it just like flexing here, if you can even. So speedy! And then you've been working on attaching these LEDs to it. And it's cool to see this because the last time I looked, you were trying to figure out how to like sort of trim off more LEDs to get it to flex faster to balance the speed with the number of LEDs you could have on there. Because the more LEDs that you add, the harder it is for it to flex quickly. It looks like you've made some good progress on here. How is that project going?
Yeah, so basically, this project I think is the my audience most favorite project. So after version 2, I got the feedback from my audience, and a lot of people wanted me to create a larger version, and that's what I tried to do here with this prototype. I also tried to make it more robust as well, but adding more weight to the coil
Mm.
will obviously make it harder and reduce the speed it can actuate at. But after doing this version 3 prototype, I think the next step forward would be to create have multiple coils that
Oh,
increase
yeah.
so increase the display size by adding multiple coils instead of having one coil
That makes sense. Yeah, because
that actuates more LEDs.
you have all this space in the middle here where you could add
Exactly.
more. Oh, brilliant. Hey, Carl, start selling the Transformer 4 leg robot, including some extra features. But
So
your
this one.
projects and products are in high demand. Ooh, ooh, show us.
So this is the Transformer robot.
Ooh.
This is also a popular project. Um, one of my, my I think it's number 3. One of my top videos on YouTube.
Wow, yeah.
Um, so this was quite an interesting project. So mechanically, it was really challenging for me to design because given that I'm not a mechanical engineer, but
Yeah.
it's quite because this robot has 12 degrees of freedom, so it has 12 servos, um, and each leg has 3 servos basically, and to create a sphere, every linkage has to fold into itself.
Wow.
So it's quite it's out of battery. I cannot for it right now, but
But you can
um,
find it on.
yeah, it's there. There's a video, 3 videos I think about it.
Yeah.
I also started working on version 2 on that, which is this guy over here.
Ooh.
But it has quite a lot. I think I over did this one, and I spent a lot of time designing this version 2. But once I printed it, I started finding other mechanical issues, which are mostly related to the printing and stuff like that. So there's a lot of other work that needs to be put into this project before actually have this version to work again.
Mm. What was your first Flex PCB project?
So the first one is the linear the linear PCB motor. So
Interesting.
basically, I first made a linear PCB motor from an FR4, which had a little sliding
Hmm.
slider on it that goes back and forth. And then I basically um, had the idea, like, what if we. I remember PCBWay started advertising flexible PCBs and announced that they have zero point 0.1 millimeter thick PCBs. And sort of I had the idea, what if you have the magnet fixed and have the flexible PCB, like, would it make some kind of movement? And the first idea I had was to try and make a robotic fish out of it
Ha!
for some reason.
That does seem
Uh,
perfect for a flexible PCB, though. It's got this sort
yeah,
of wiggly motion.
yeah. I did make a prototype, a really rough prototype of a robotic fish, but it's it needs a little more work on it to be feasible, because obviously you would need to make it waterproof and stuff like that.
Right. Yeah, yeah, yeah. You have a video up recently answering the three most common questions you get asked. Can two flexors attract each other? Obviously, people can watch the video to see
Yeah.
all the
The,
actual answers, but like, yeah, can they?
in that video, I tried to combine a lot of questions people ask me. Um, it's because one of the questions that I receive a lot is to use that magnetic film to observe the magnetic field of
Oh
the
yeah.
coils, which
Okay.
obviously doesn't work because the coil's magnetic field, when compared
It's so
to
dense, right?
neodymium magnets,
Mhm.
it's not strong enough.
Oh, interesting.
Um, so neodymium magnets are pretty strong when compared to coils. So that's why I mean that's why they interact the way they do. Um,
Ah,
then the other question I try to answer is, can two flexors attract each other?
I would
And
assume yes, right? Because you could do make one of them a north and no?
the displacement would be is very small. Like,
Oh.
but when I tried to add magnetic magnetic cores on top of the flexible PCB, it managed to do it.
Ah,
So
cool.
if anyone is interested in seeing the results, you can see everything in the video. But
You
that was quite an interesting experiment.
Your production quality on your YouTube videos is just incredible. And I know that we have a lot of people as well who make their own projects and want to share their own projects. What are your tips, or what would be your number like 1, 2, and 3 tips for people who are trying to document their own projects and make beautiful videos? Because yours are just spectacular.
Thank you. Thank you very much. I don't see them that spectacular, but thank you. um,
So good. You've got like camera switching between like your face and the thing, and then like, no, so much good stuff.
so I mean, my suggestion would be to obviously start and then improve over time. I mean, if you see some of my first videos, they are terrible. So,
What kind of camera are you using here?
so I'm using a DSLR Canon
Mm.
here, an 80D.
And you've got time lapses, you've got focus changing, you've got all of them. Have you created any custom camera controllers, or are you just using sort of what's around?
No, not yet. So to create these shots, what I usually do is um, obviously the types of shots I create
It's so
are like
pretty.
to create these types of shots. I usually assemble two PCB, so that's why I get different angles.
Oh,
So
oh! So instead of like having two cameras, you do it
exactly.
twice, and then oh,
I,
that's
I
smart.
would still have two cameras capturing the
Oh,
thing and then
ah.
redo it. So we would have multiple shots.
I love these
So
shots
that's
where you're just
a little trick.
mm. I love it where you're like superimposing the labels on the components on the board. This is so good. Ah, and then it's real. Okay, let's see. I have to stay on track. I think I might have run through all my questions for you, but there's so much still to explore. So much that it's becoming a problem for me. Again, it's like it's really distracting going through your whole portfolio here because there's always more things that I haven't seen before. It's really incredible. Is there anything that you'd like to throw in there before we wrap up? You have your Patreon.
Yeah, I have Patreon, so anyone who would like to support my project can do it over there.
Is there anything else that you would that you feel you didn't get a chance to talk about that you would love to highlight, or things coming up in the future that you'd like to talk about?
Okay, so in the future, so I currently have my next video was probably going to be about the PCB motor version 4, which is hopefully an improvement from the version 3. And based on those results, I'm going to take those improvements and apply them to the PCB wheeled robot sometime in the near future. Then I obviously have the PCB heater lined up, which is what we talked about a few minutes ago. And I'm also doing some interesting things with coil and coil design.
I'm especially interested in the PCB heater one because it's sort of like with the coils. You're taking these physical projects aspects of the PCBs themselves and using them to create effects where usually, often it's just like a control board control a different actuator, but in this case you're using, the physical substance of the PCB to heat it. You're using the physical, coils on the PCB as actuators and motor parts. I think that's just so brilliant. You like see beyond. You see them as objects in and of themselves, and the PCB itself as a material for creation, and not just as a way of controlling something else. I think that's just so brilliant. I can't wait to see what else you come up with.
Thank you.
For the future, people can follow your projects at the links in the description. We've got Twitter, Instagram. Here we go. YouTube, of course. I'm spending way too much time on there in the near future. Patreon, and of course, Hackster.io, my favorite website. Thank you so much for joining us, Carl, and thank you everyone for best day ever. All right, I'll see you soon. Maybe, I don't know, someday in the real world. Everyone, we'll see you soon. Have a great one, and ciao.